Okay, we're talking about quiz 24 in particular. We've got a hairspray bottle spraying out little drops of hairspray, and it turns out that the droplets have a certain separation and they also have a charge. So what you're thinking about is a spray, and what comes out are these little drops. And the drops are small, but of course the charges on things are even smaller than drops. And so it looks like they have a charge each of minus 16.02 times 10 to the minus 19 coulombs. So coulombs the unit of charge. And in this case, the charge on an electron over here, check it out, is 1.6 times 10 to the minus 19 coulombs. So when we're talking about 16 times 10 to the minus 2, we basically have, well, it looks like 10. So I think that's the answer to one of these questions. How many electrons has each sphere picked up? So if the charge on an electron is 1/10 of this, then it must have picked up 10 of them. So we'll say 10 electrons. And then let's see, is the force between them attractive or repulsive? So if we draw our little picture of a drop with some negative charges on it, and another drop, some negative charges on it, identical drops, identical number of charges, what we'll see is, or we'll remember from our model, that negative or like charges repel. So these drops are going to feel a force pushing them away from each other, separating each other, because remember, charges of the same type don't like to be close to each other. Alright, and then what law describes electrostatic force? It's called Coulomb's law. It's the topics that we're studying right now. And furthermore, if these charges are separated by 2 millimeters, or 0.002 meters, then we can figure out what the force on the charge is, F sub c. They are repulsive forces. Because like charges attract. Sorry, like charges repel. Okay, now part D. What's the value of the electrostatic force between droplets? So we're talking about F of C, the Coulomb force, K times Q1, Q2, all over the distance between the two charges squared. So K is 9 times 10 to the 9th. I got to remember to write that on the paper. Newtons meter squared per Coulomb squared. So that's K times the charge. So we've got each drop has this charge on it, 1.602 times 10 to the minus 19th. So we've got minus 16.02 times 10 to the minus 19. And I'll just square that because we're working together. And then we're going to, this is in the way here now, let me get rid of this. We're going to divide by the distance between them squared. So 1 over 0.002 meters squared. And this is coulombs here, and it's going to be squared. Okay, so 9 times 10 to the 9th Newton meter squared per Coulomb squared is K times charge 1 times charge 2. The charges are the same. We're going to square that. And then all divided by 2 millimeters squared, or 0.002 meters squared. Let me grab my calculator. Put those in. Do I have my fancy calculator simulator? This computer. Okay, so I found my calculator. Let's plug this in. So 9 times 10 to the 9th on clear. 9 times 10 to the 9th times 16. I'm going to leave off the negative sign because it's not going to affect the magnitude of the force. Times 10 to the minus 19. All that squared. I don't know if that's going to work here, so let's, just to be really careful, let's put in parentheses here. So I want 16.02 times 10 to the minus 19, that squared. All times 1 divided by 0.002 squared. So then that equals, okay, so what we've got is the electrostatic force 5.77 times 10 to the minus 21st newtons. So let me write that down here. I guess I didn't leave much room here, so 5.77 times 10 to the minus 21 newtons. So a very small force, but again, the scales are small, and we do see droplets kind of spread out after we spray them.